So let's do the scallops on our desk here. So if you don't have it in edit mode, click on edit in place. And now we're going to start building the voids. Now the voids are going to carve horizontally, because if you look at the scallops, you can see that they are being drawn sort of sideways here as a void. So we're going to go into the south or north elevation. I'm not sure which one you folks would need. So I'm going to build a void that carves into this thing. Now, the problem that I have right now is that the scallops, they don't know. So here, if we did a void form, a void extrusion, which is what we're going to do, it's going to be a half circle top with a basically 180 degrees of a circle. Revit's like, which plane are you drawing this thing right now? So we're not defined front to back into view here where this extrusion is going to sit, this void. So before we get started, we need to go back to the plan view, and there's our desk. And so we need to define a starting point for this void extrusion to live on. So if you folks go to the level 1 plan view, make sure you are in the family editor, inside the in-place family, and go to the create tab and find that reference plane tool again. Now, once the reference plane tool is active, just draw a short reference plane across the screen horizontally. And we'll give this a name, and I'll just call it void. So this is going to be the plane from which our void extrusion starts. So we need to be now looking at a view that looks at this void perpendicularly. So I'll go back to the south elevation. So now, create void forms, void extrusion. So now when you see this dialog box and Revit is saying, hey, where are we starting from here with this extrusion? Choose void, the one that we just added, the one you just added. This is why naming reference planes is so important. Hit OK. So now here we go. So now we're drawing the void. So what I'm going to do here is use the 3-point arc tool, and I'm just going to draw an arc. Click anywhere, drag sideways, type in 1 for 1 foot, and make it so again it's 180 degrees of curvature. So your arc is going to look like that. So once you've drawn the top part of the circle, just use the line tool and draw the bottom part of the circle. So your circle should look like that. Now we need to center this thing on this void. We want to center it on the desk. So what you'll need to do, just hit escape a couple of times so that you are not in a command. And I'm going to select that geometry that we just drew. This is the sketch for our void. Select it. And then use the move command to move it. And we're going to move it so that our starting point is the center of that curve. That's click number 1. And then click number 2 is to type in SM first to ask for a midpoint snap. And then put our cursor on the bottom edge of the desk so it finds the midpoint of that curve, and it'll move that geometry over so it's right in the center of your desk. So once that's done, you can just click somewhere. Before we go any further, make sure that in the properties palette that it says void. Now, I see a lot of you folks who are working with your properties palette and your project browser stacked. That is wrong on so many levels. It's just so hard to work with. What you folks need to do is grab the properties palette and just drag it into the drawing area, and then drag it over so that the cursor, this cursor here, touches the scroll bar on the side, and you'll see it dock. Drag, 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 dock. You get a blue toned rectangle, release your mouse, and now your properties palette is docked on the other side. This gives you more room to see everything in your project browser and more room to see everything in your properties palette. Okay, so you can hit finish, and we'll go to 3D here, and we're just going to look for our void. You can see it there, it's orange. Voids are orange when they aren't cutting anything. Now, if you see your geometry here and it's gray, that means that you've accidentally started off with the solid modeling command. And in the properties palette, if you click it, you can switch it from a solid to a void. And it should be orange. Now, you can see that my orange is not in the same vicinity as my solid. So as you can imagine, you just have to click it and grab the back triangle here and just drag it over until it's intersecting through the bottom of the desk, like so. Now, it's not cutting it yet. So find the Cut Geometry tool and choose Cut Geometry. And once the Cut Geometry tool is activated, pick the void and then the bottom of the desk, or the bottom of the desk and the void. Doesn't matter what order you do it in, and it will create the hole. Once a void is cutting through geometry, it kind of hides itself. It is still there. When you put your cursor on top of it, you can see the void is still there. So if you wanted to move it or edit its shape, that is still possible. So what we're going to do is we're going to go into the plan view here. So go back into the plan view, and we just want to copy this void around. Now we can't see it. The counter is obscuring what's below. If we want to kind of look down and see where that void might be, what would be the thing to do here, folks? What I got to do is my view. Wireframe, exactly. So I got to switch my view to wireframe here so I can see through. And there is where my void might be located. Now, if you don't see the void, you can see sometimes it's going to show up. Put your cursor in the vicinity, right? Hover, hit the tab key once. There it is. So now we can click it. So now the void is selected. And we're going to rotate copy it. So I'm going to put one at 40 degrees and one at 80 degrees. So watch carefully when I'm going to go through here, and I'll do it twice, and then you folks will have the feel for doing it yourself. So we've got the void selected, going up and grabbing the rotate tool. So again, just wait until I've got this done so you guys can see the process you're going to have to go through. Rotate, choose copy. So rotate and then copy. And right now Revit wants to put the center of rotation at the geographic middle of where that void is sitting. We don't want to rotate around here. We want to rotate around the center of the desk's curvature. So what we have to do is either hit place or spacebar. That allows you to redefine where the axis of rotation is going to be for the copy command. So you hover over the desk and type in SC for snap center, right? Then once you've started the rotation, again making sure copy is checked, click anywhere and drag for 40 degrees. So there's our second copy. So again, let me show you how it works. Hover, tab, click, copy, and every time you use the rotate command, you have to recheck the copy tool. Then spacebar to move the axis of rotation. Hover over the curved part of the desk anywhere, any one of the curves, SC. Now when I left click, that's our new center of rotation. Click anywhere and keep going another 40 degrees. So you should be able to get this. Oh, you know what I did? I forgot to hit copy, right? So there you go. The instructor blew it. So hover, tab, click, rotate, choose copy, Now the copy mode is enabled. Hit the space bar. Space bar is not working for some reason, so I'll hit place. So now I can move my center of rotation where? SC, snap center, center of the desk. Damn thing switched my copy mode around. Ugh. 40. There we go. So to finish it, you can just mirror these two to the other side, whatever. Okay, I'm going to move on here, folks. So if you want to just finish your model, do not get rid of this file. You will use it later. We're going to move on to page 3 here. So I was mentioning to you how in Revit we can bring geometry in from other programs, Rhino, AutoCAD, what have you, even SketchUp, to use that geometry inside Revit. Now, on the Insert tab, right, there's all the tools you need for inserting that geometry in your project. Now, here's the wrinkle. If you bring that imported geometry in while you are working in the in-place family mode, Revit treats that inserted geometry as the category that you chose. We're going to bring in a roof from SketchUp. So what we're going to do here, page 3, let's go through these points together. South elevation. We need a story called roof that is 20 feet above level 1. So what we'll do here, folks, is we'll hijack the level 2 plan view and we'll call it roof instead. So take level 2 and rename it as roof and make its height 20 feet, just like you see here. So do that in the south elevation view. And then once you've renamed the view and the level, go to the roof plan, and you'll still see your desk down on the bottom there. And we're going to import a SketchUp file, which you will find in tonight's share out folder. Now I am just using this other program here, so go onto your, when you're going to the import in a second, you'll have to, you'll be going to a different path than I am here, so just give me a second here. I'm going to download this stuff. All right. So what we're going to do now here, folks, go into the roof plan. We are going to make another in-place family. Go to the Architecture tab. Second bullet point, page 3, if you're going to follow the notes. Choose Architecture, Component, Model in Place. Now this time, we're going to choose the roof category. Now you must have started the in-place family before going on to the next step, so don't continue until you've started the in-place family command and you've chosen roof as the category. Okay. Now it says SketchUp roof. That's what we're going to call a SketchUp roof. Okay, so this is going to be roof geometry that we're bringing in from SketchUp. All right, so what you guys need to do now is go to the Insert tab. Insert tab. So again, you're inside an in-place family, and you can tell because you've got the Create tab and then the Insert tab. So what we're going to do is we're going to import some CAD geometry into our in-place family. And Revit's going to treat that family as if it was a Revit roof. So we'll be able to attach our walls up to it. So go to Import CAD. And then navigate to the Share Out folder, BLDG 2805, Session 4, and inside the Session 4 folder, if you switch to the SketchUp drop down. So where it says files of type at the bottom here, right here, switch to Sketchup. And in the Session 4 folder, you'll find Sketchup Roof. I'll just leave this up here on the screen for a second so you folks know where you're headed. And if you can't find it, just wave, and Henry and I will get you set up.
Sorry, it's the J drive.
It is the J drive, yes. J BLDG 2805 Session 4. So again, you got to make sure that you choose files of type SketchUp at the bottom. Go ahead and hit open once you've picked the SketchUp roof, and you should see the geometry appear here. It kind of puts it in its own location. What I want to do is I want to center that thing on top of the desk. I'm going to unpin it so I can move it, and then just drag it so it's sitting right on top of the desk that you've drawn. Okay, so Revit is going to treat this geometry as if it is an actual roof object. So when you hit finish, what's that? No, it's you got to switch to files of type SketchUp. All right, so go look at it in 3D, folks. So there's our desk, and there's this roof, which is kind of sitting over top of it here. So Revit thinks that that gray piece there, made in another CAD program, is a roof. Put your cursor on top of it. It says roof. So that first bit of description there tells you what category it is, and Revit is going to treat it like a roof. Okay, so back to the roof plan. How come we don't see the roof? Anybody? Can't see the roof. What's going on? What should we do to fix the problem? View range. I hear view range. Yes, indeed. So oftentimes our view range is not high enough, especially with the cut plane. So if we make the top and cut plane both say, 88 feet, that should be enough for us to see our roof. And there it is. Now what we're going to do here is show how our walls in Revit can attach upwards to our roof. So the next step here, once you've got the roof in place, is to go to your level 1 floor plan. And what I want to be able to do is to see that roof above in my floor plan. Now, I don't know if this is something that you folks have tried before, but this is a really great use of the underlay feature in Revit. So in your level 1 floor plan, you can ask for Revit to show an underlay of another story of the building, right? So it'll show the second floor plan, the third floor plan. If you want to see it, it'll show it in gray in your view. But what I want Revit to do is to show me my level 1 floor plan, but looking up. So it's kind of like making a reflected ceiling plan happen in your floor plan. So as soon as you set your range to level 1, looking up to the roof, and change the direction to looking up, now Revit will give you a 50% gray rendition of the roof. Now it's not, there it is. I had to switch to unbounded. So what it means is I'm starting at level 1 and I'm looking up, and this allows me to see the roof above here in this view. So again, range level 1, top, unbounded, looking up. Now, this allows us to see where the roof is sitting above us here. So we're going to zoom in a little bit here, and we're going to put in some curtain wall. So grab the architecture tool here, architectural wall, and then go over to the properties palette, and we're going to use the storefront. So storefront as our wall type here. Have a look on the screen here. I'll show you what we're going to be doing using the arc tool. So we're going to do something that's a little funky here, so you can see that the walls are going to have to do some work to attach up to this geometry that's above us. So I'm going to click here, starting in the close to the lower left corner of the roof, up sort of angled to the other corner here. I'm giving it a little bit of curvature, so this is my third click. Then just kind of over towards the top right corner, that's my second click. Here's my third click. Another click down here, giving it a little bit of curvature but not going off the roof for my second click. And then back to where I started and giving it a little bit of curvature again. So just curtain wall, but they're all curving. That is what you should see at this point. So all of this curtain wall here is going to, what I want to do is attach it to the roof overhead. But we drew it, first of all, in the level 1 plan with the underlay turned on so we could look and see the roof above. So this is kind of like a, a tourist information center with a fancy roof on the top of it. Yeah, you could absolutely have made this geometry in Revit. For the roof, no problem. But we're just showing how you can bring that geometry in from somewhere else, and Revit will treat it as its own geometry. So what I want you folks to do now is just put your cursor on one of those curtain walls, and you'll see a dashed, well, here. It's kind of faint to see, but when you put your cursor on the edge of the curtain wall, you'll see dashed blue lines along the top, bottom, and sides. Do you folks see that? And that's what you want to do. Just put your cursor right on the edge of the wall. Now there I'm getting a mullion. That's not what I want. So I'm just going to move my cursor by a few pixels. There we go. Just a pixel or two. So that means I'm grabbing the whole wall. But I don't want to click it. I want to tab it. One tab. And that's, you can see it's picking all the walls all around the perimeter. So once all 4 walls are pre-highlighted, so again, move your cursor in until you see the dashed blue line at the perimeter of the wall. Hover, right? So this is hover, but not the mullion. Hover on the wall. Hover, tab, click. So now 4 walls are selected, and I want to attach them and pick the edge of the roof. So Revit is now going to take this curtain wall and extend it upwards until it touches the underside of the roof. Revit is going to have to delete the mullions that were there originally so that the curtain wall can keep going, which is fine. So that is the final destination of this exercise, and you can see how the mullions and the curtain wall, it's trimming itself to meet the underside of this crazy roof. So a lot of architects use some other software because they're good at it to build some kind of crazy roof form. Bring it into Revit because Revit's really good at doing drawings, and they'll bring that geometry in an in-place family. So put that in there with your desk, and then at the end of the notes there it says save this project as your last name, in-place model, and you can put it into your folder on the share-in drive. Okay, so I'm going to skip the in-place trellis modeling. That's actually on another YouTube video on the channel, so you can check that out. I want to move on to massing because this is going to take some time, and we've only got a little bit more than an hour left, and I want to spend some time talking about it. All right, so I will save this here. So all right, so if you folks want to save your model, close it right back down to the desktop so you have nothing else open, and then open up the new architectural template. We're going to move on to massing, page 7 in the notes. Okay, so what I'm pulling up here are some images that showcase some of the purposes that the massing tool set was built for. There's two sort of general workflows that the massing tool set is meant to support. So if we look up at the screen here, one of the workflows that massing supports is the concept of the building maker. So something like this. This is where we're using massing tool set to quickly build the envelope of a building and then use it for schematic studies. With the massing tools, we can build up the form of a building, and we can quickly figure out what its gross floor area is. So in the very early stages of a design, particularly with towers, where the shape of the tower is kind of known, we will use the massing tools to build up the building's rough shape and do some studies on how much gross floor area we can get out of that form. I'll show that in a moment. The other workflow that's used with massing is to panelize it. Now you're seeing some examples of it here where we've got kind of a draped form, and then it's been turned into a grid pattern, and inside each one of these cells in the grid we can put a special kind of panel which is unique to massing objects. So that's the second workflow, panelization. The other workflow, which I'm not sure if it's shown here, but we'll look at it as well, is to use the massing tool set in conjunction with the regular Revit wall, floor, and roof tools. And it's a mode called wall by face, roof by face, floor by face. So you've got these three sort of different directions that we go with the massing tool set. Okay, what we need to do here, just for this particular exercise, if you folks want to go to the south elevation, this is going to be just a throwaway file, but I wanted to show you folks how it works. Click on your level 2 in your south elevation, and we're going to use the array tool. So what we're going to do here is we're going to quickly model up a 50-story building. You're like, really? Follow along. So you grab the array tool. Before you do anything, uncheck group and associate. I don't want to make this an array group. I just want to array the floors up. So you pick the level 2, uncheck group and associate, click on level 1, and then straight up to level 2, so we get 10-foot floors. And I forgot to put in the number, so let's try that again. Array, uncheck group and associate, number here, we're going to put in 49. So we're adding 49 more floors. Unchecking group and associate, click on level 1, straight up to level 2. There we go. So we got a whole bunch of extra floors added. We don't have floor plans for them, of course, because when you copy levels in elevation, Revit doesn't make plan views of those floors when you copy them up. Does anybody know what you could do quickly to make plan views of all of those floors? Anybody know? Yeah, that's right. Plan views drop down. That's exactly right. On the View tab, if you've got a whole bunch of levels that you've copied, so if you just copy up a level and you don't use the level command on the architecture tab when you're drawing those, to draw those levels, you just copy them up. Revit doesn't create plan views when you merely copy a level in an elevation view. So if you go to the View tab and you go to the Plan Views drop-down, inside the Floor Plan dialog box, Revit will list all of the levels for which no plan view yet exists. So you could make all the floor plans you needed at once. Just click on level 3, shift click on level 50 and hit OK. Don't do that because it'll take Revit a couple of minutes to create all the plan views, so we'll just cancel. So here we've got a whole bunch of levels. Now, let's make a building. Let's go back to level 1. And let's look at the massing tool set. Now there's two ways that you can get into the massing tool set in Revit. Number one, you could use the model in place menu just like we did moments ago, but we would choose the mask category. So that's one way of doing it. The other way of doing it is go to the massing and site tab and choose in place mass. So if you do that, Revit makes an in place family in the massing category. So it kind of skips the one step for you. So I'll show you. You folks go ahead and hit in place mass and then call it mass and just hit enter. So go ahead and hit in place mass. There'll be a message that Revit pops up. We'll talk about that in a second. Just call it mass and hit enter. I am going to go to the architecture tab here and choose model in place and choose mass and show that you can get to the same destination by taking both routes. All right, welcome to massing world. So the idea with the massing tool set is that you can assemble different 2D sketched geometries to build a form. So let's just start with something basic. Grab the rectangle tool and just draw a rectangle on your screen. So these are massing lines. Now, these are just 2D at this point. When we want to start building something that's three-dimensional, you've got to go back to modify mode, so just to escape a couple of times so that you're no longer drawing geometry. And you'll notice that when you put your cursor over the geometry you've just drawn, Revit wants to select it all at once, kind of like Sketchup before you do a push-pull. So now if I click on these lines here, Revit, up on the ribbon, says create form. So this is kind of like the beginning of our push-pull. So go ahead, and you can see you can make a solid or a void form. We're going to make a solid form. So it's created this extruded rectangle. Let's have a look at it in 3D. And there it is. And all the different stories that we've created are in the background there. So now that we've created this form, you can put your cursor on it, and you can see you can grab a plane or grab just a line. What we're going to do here is grab in 3D, grab the top plane of this thing. And you'll see it, there's a blue handle that will allow you to take this extrusion and just drag it upwards, like so. Okay, let's start from scratch again. Let's just show you how you make the geometry. I'll stay in 3D. On the drawing up here on the top of the ribbon, just grab the line tool or the rectangle tool and just draw a shape. So once that shape's been created, go back to modify mode and put your cursor on the shape you've just created. Now you hit create form, and Revit creates a solid, and you can now stretch it up. So you can pick any one of the faces and drag it out. Not only can you grab faces, you can grab lines, and you can drag the lines out. And not only can you drag the lines, you can drag a vertex out and up. So you can start making this thing quite a bit more interesting. I have no idea why it didn't draw it on level 1. Okay. My building is floating up in the sky. That's awkward. When I started my drawings here, I didn't use the set work plane tool when I was first drawing these lines here. Have a look here where it says drawing model lines. It says placement plane not associated. I should have picked level 1. So these model lines really can just sort of float around in space unless you are you're intentional that when you first create those model lines that you associate them with one of the levels in your project if you don't create them in plan in the first place. If I had created this second rectangle in a plan view, that problem with my building floating in the sky wouldn't have happened. So yeah, create form, there's our shape. And so in 3D, these things are quite plastic. You can just stretch them up, grab these different planes, lines, edges, and you can pull them around. So there's our shape. And of course, we can bring these shapes together. I can do it here in 3D. So in 3D, I can use the top of the view cube, and then I can select this geometry, and I can bring it over. And see how they're overlapping and intersecting? I can use the join geometry command and merge those two geometries together to create a single entity. So there's the join geometry tool. So if you've got two different forms, intersect them, and then use the join geometry command to merge those two forms together. And you can see what's happened here. So if you've kind of got an idea for the form of a building, you can use the massing tools to see how much floor space you'll get out of it. Now this is kind of a function follows form exercise in a lot of ways, right? So unless you've got a floor plate already kind of figured out with some dimensions for it, this exercise to me is a little bit about, let's do something that looks cool and see how many square feet we get out of it. So once you've modeled up your geometry, of course you can go to the model tool, and instead of creating a form that is a solid, you can create a form that's a void, right? So here in my level 1 view again, watch this. I'm just going to draw some lines here. So this is I'm looking at some geometry here that's been extruded, a form's been built, and now I've got some 2D lines that I've drawn in plan, and I'm going to create a void form. And sure enough, if we look at it, there's the little triangle that's been cut out of the bottom here. And I can tab, select it here, and I can increase the size of that void. So you can use solids and voids together, join geometry, cut geometry, to make these solids and voids interact to create the overall form of a building. Now, with all of those levels that are in the background, those are what get us our floor area. So what I'm going to do here is I'm going to hit Finish Mass. So there's my building form. Now to get the floors, you select the building, and you folks can see mass floors on the ribbon. So once the massing has been done, go up and choose Mass Floors. And I can pick level 1, and shift-click the last level, and check them all. And what Revit does, if I turn on shading here, it creates those purple planes. Those are called mass floors. And once you've created them in the project browser, it's telling me I have 1.6 million, is that right? Yeah, 1.6 million square feet of gross floor area. So a very quick way that you can get some areas based on what you've modeled. And of course, if you go back later and you click your in-place family, when you're editing it, it doesn't show the mass floors. But now you can change the shape of this thing. And when you're done, Revit will update your gross floor area based on the new shape. So here I'm up at 2.1 million square feet. So this is Building Maker. So I'm not too worried about showing this to you in great detail tonight. At least you guys will have this video if you haven't been able to follow along. I will slow down for some of the other components of this that I think are more important for you folks to deal with. So that is Building Maker. Now, once you've finished the mass, what I want to do here is point you folks to the tools that I've been talking about. Wall by face. Roof by face. Floor by face. Face of what? Face of either a mass family or a generic model in-place family. So both generic model and in-place families, generic model and mass in-place families, both of those categories allow this roof, floor, or wall by face to work. Observe. And I come over to the front of my mass here and see how the wall is sloping outwards? So now what I can do is use wall by face. I can pick the front face of the building here, and there. That's just a regular Revit wall that's been skinned onto the face of a mass. So if you need to do a sloping wall that leans in a particular direction, the massing tool set was meant to assist in those applications. So that is under the on page 6 here, under massing workflows, we just looked at point number 3. Wall by face, roof by face, floor by face. Now we're going to look at the other 2 workflows here, creating forms and dividing a surface. So the creating form, that's what we're doing right here. So this is kind of steps 1 and 3 together. We're building forms and then using the by face tools to skin those assemblies onto the face of a mass object. Now I am going to close this file and not save it. And what I want to do here is point out the conceptual mass environment, which is at the top of page 6. This is kind of like the massing tool set that we saw, but it's kind of outside of the regular Revit environment. It's a bit of an oddball thing. And let's, if you folks want to, if you want to save what you've been doing, that's fine. Go ahead and save it. And then get back down to the Revit desktop like you can see I've got going on here. Now, to get to this conceptual mass environment, if you folks hit new, nope, not new, families, new, families, new. So under families, new, go to conceptual mass, into the conceptual mass folder, and just double click on mass. So again, go to the family section, go to new, and then straight away go into the conceptual mass folder and double click mass. Okay, so this is the conceptual mass environment. What this is it gives you all of the massing tools and none of the Revit tools. The purpose of this is to provide a stripped down interface just for massing work, so you can have design work going on without any of the overhead of the regular Revit environment. So what would happen is after you build the form of a building that you want, you'd save this. It would be saved as a family, just like a door family, and you would import it into one of your projects. So this is a conceptual mass environment. So same tools, same thing here. I would click the level, like see you've got your elevation views. So what you would do, there's my levels, and I just take those levels and I'd copy them upwards, just like in a regular project. And so once I've got all those levels, I'll see them in 3D. They'll all be stacked up. And then I can model, bring it into a project, and do whatever I want. So we're going to move on to the creating forms in an in-place family and then dividing a surface. So the idea with this is that it's its own family that represents the form of the building that gets saved as its own family and then imported into a project. So like this, load into a project. So you guys can do some Googling of the conceptual mass environment. I've never actually used it on a project. There's probably some firms that do, but I tend to use in-place masses within the context of a project. So let's do that. Let's start with a new architectural project using the architectural template here, and let's carry on. So what we're going to do here is we're going to create a form that is a little trickier. Let's go over to the masking toolset on page 7. And let's start up an in-place mass. There are two kinds of geometries that can be used to build a mass form. On the left, you folks will see that there is model geometry and reference geometry. What's the difference? Well, folks, I want you to click model and make a rectangle. So click model and make a rectangle, and then I want you to click on reference and then make a rectangle. So there's going to be two rectangles right beside each other. They will be different colors. The reference geometry will be green. The model geometry will be black. Now when you pass your cursor over these two different geometries, they look really different when they're being hovered over. The reference geometry has all these extra dashes and stuff. And the model geometry, the black lines, you can just see the dots at the endpoints. Now what I want you folks to do is to make forms out of both. So click on the model geometry here and create a form. And then click on the reference geometry and create a form of that as well. At the bottom, Revit asks, only with the reference geometry, do I want to make a solid or do I want to make a surface? Solid or surface? We'll do a solid. So that's the left of the two options here. And in 3D, when we look at it, they kind of look the same, but their functionality is quite different. When you start creating mass geometry using model lines, those original model lines are subsumed into the resulting mass. So this one on the left here, that was the mass form that was built from model lines. The original model lines are gone. So if you guys have ever seen the horror movie The Blob from the 1950s, that's what's happened. The Blob came and ate those lines up and they're gone. They're gone. Mass geometry that has been created using model lines is very plastic, as in you can grab these different pieces here and you can twist this thing around, and like I said, you can grab faces. You can grab lines, and you can put your cursor and grab vertices as well. So you can just push-pull this thing in all different kinds of directions. And once that's done, you can use the wall and floor and roof by face tools and put your everyday Revit wall assemblies, roof assemblies, floor assemblies onto that form. Now what about the reference geometry? When you put your cursor over it, those are the original reference lines. They do not get subsumed. They exist, they're maintained. The massing form that you get out of it can only be changed in height. I cannot grab an edge of it and pull it around. So how do I change this thing's shape? Well, what you've got to do is adjust the reference lines, and the reference lines drive the shape of the resulting mass form. Now, this is actually important. Here's the thing. Let's say that you are going to build a curtain wall that follows the edge of your slabs. So in your model, you've got all your different floor slabs, 17 of them for your building. In your massing in place family, you can draw reference lines on each one of those floors around the perimeter of the concrete, all the way around the building. Once all those different sets of reference lines have been created on each floor, we can create a massing form using that entire set of 17 different perimeters for the slab and make a single mass form out of 17 loops of the floor all the way up. So what we're going to do here is we're going to build a second set of lines on level 2. So we've got our first set of reference lines on level 1. Now we're going to make a second set of lines on level 2. When you delete this mass form that was made with reference lines, the reference lines are still there. But if I delete this mass form, the whole thing goes away and the original model lines aren't there anymore. So what this allows us to do is to make a mass form that's built on very specific geometries that we've defined inside our project, and use the mass form to help us build curtain walls and other, regular walls in our project that we would have no means of easily doing otherwise. You could make an in-place family, but that would be pretty laborious. So if you think of some of the towers that are around here on the waterfront, some of them have curved glass, curved in plan, and curved in elevation. So this process here can facilitate that kind of geometry and make it so that as you move those reference lines around, your curtain wall is automatically changing its shape to follow the new form that you want. So what we're going to do here, we just put our cursor on top of this mass form. I'm going to tab once, grabbing the whole thing, left click, delete. You should still see your reference lines there. So what we'll do is once we've deleted that original mass form, I'll leave the model line mask for now. I'm not worried about that. Let's go to the level 2 floor plan here, and you should be able to see your reference lines from the next floor down. So use some more reference lines and draw a shape that's kind of similar to the one that's there. It should have as many segments as the one that you drew below. So I had 4 segments on my first floor set of reference lines, and I'm making 4 for those on level 2. Now, I think just what we'll do here for the time being is I want to add one more level so we can use 3 different sets of lines to do this. So in my south elevation here, I'm just going to I'm going to copy up another 2 floors. There. Just give yourself a 3rd and 4th floor, and we'll go back into the in-place mass and build those extra loops. Let's make floor plan views for level 3 and 4 as well. So make sure that you've got plan views of all 4 of those levels, because we want to be able to draw on those floor plans. So again, the process that we're replicating here is a situation where you've got the slab outlines already sorted, and now we want to put the skin on the outside. So once you've got those 4 levels created, select your in-place mass. And Henry, do you want to give some help here? So there's our in-place mass, and just choose Edit in Place. So now in your level 2 floor plan, you should be able to see those reference lines again. So what we'll do now is go to our level 3 floor plan and draw another set of reference lines. Now, why can't we see level 2? Yeah, it's view range. So if we wanted to fix our view range in level 3 while you're inside the in-place family, you don't have to actually quit your in-place family to change the properties of this view so we can see down to level 2. All you have to do is click level 3 in the project browser, and the properties palette will show you the properties of the level 3 plan. Neat trick, hey? So now what we're going to do here is I'm just going to set up my underlay of level 2. So this allows me, in my level 3 floor plan, to see an underlay of level 2. Of course, I could also take my view range and make it so my view depth goes down to level 1. And then I'd see whatever. I'm not going to bother with that, so I'm just going to leave it so I have an underlay of level 2 while I'm in level 3. And I'm going to draw some more reference lines. Again, a slightly different shape from the one that I've got here. So we look at this thing in 3D, you can see we've got a variety of different shapes here. Each set of those reference lines on a different floor. So the idea being, each one of these represents our slab edge, and our curtain wall is going to be built on the face of that. So what Revit is going to do, we're going to use Revit to connect the dots between all these different pieces together. So we've got a skin that wraps the building and goes from floor to floor at each. So here's the deal. Mass forms can be built from one or multiple loops. So if you want to make a mass form of multiple loops, hold down your control key and select them all. You get this mess of blue geometry on your screen. But now we can create a form from these multiple geometries. There you go. Now, everybody's like, well, hold on a second here. Those are curved forms. Can I get a straight form? What if you just want to create straight lines? So instead of making this all curved, can I make it so that it's more straight? And the answer is yes. But what you need to do is just pick the first and the second floor loop and then make a form. Okay, what about the next one? Okay, fine. Pick level 2 and then level 3 and then make a form. So you can see this one's much more angular looking and obviously cheaper to build. So the process of making a form depends on whether you have multiple loops selected at once or just 2. So in this case, by only selecting 2 loops at a time, I'm able to get very straight line connections between each floor and the next. So now if any set of the reference lines changes its shape, the mass form automatically updates itself to the new location of the reference lines. There is no similar process that we could go through that would iterate with them if we use model geometry. So when you're using model lines, we could have drawn model lines on each one of those floors, but once we made the resulting form, the original model lines are gone. So this one here, you keep those lines, and it's good as that's why they call it reference geometry. It's going to be maintained. Okay, so let's talk about the some of the other panelization options here. Once we have these forms here, these forms can be panelized. So what happens is you put your cursor over one of the faces of your mass after you've made it, and tab until that one face is highlighted. So put your cursor over one face on the edge of it and hit the tab key successively until that face is highlighted, and now left click to select it. Now, up on the ribbon, you will see divide surface. So what this does is it turns the surface into that grid that we saw earlier here. So there's, you folks see this this grid, these purple lines. This is the grid, massing grid. And that's the one that you see on my screen here. Now you'll notice that Revit calls these grids not X and Y, but U and V. Because of course they're not really XY grids, but U is the number of grids you get on one side, and V is the number of grids that you get along the other side. So you can decide how many grids you want on each face. So once you have panelized a face, put a grid on it, now we get into something that's really interesting. Select that grid that you've just created, and if you look over on the properties palette, it says no pattern. So here we're just seeing the U and V grids, but a pattern hasn't been chosen. Regardless of what this shape might take, what would be the cheapest geometry that we could use to build this piece of wall, no matter how tortured or twisted it is? What's the simplest kind of geometry? If you could think of a different number of polygons that could be used to fill in each one of these blanks, you can build anything out of triangles. So when you look at a space frame, they'll build it out of triangles. So you got a rhomboid shape that's like totally like crazy. They'll cut it in half and make a triangle out of it, and it can be built. So out of this list here, there's a whole bunch of different geometric shapes that could be used. Let's take the bent triangle. So that is how triangulation would be used to fill this in. So that's triangles. Let's look at how rhomboids would look. So that would be a rhomboid-based pattern. Revit has special kinds of families that are meant to fit into this pattern. They're called pattern-based curtain panel families. Pattern-based curtain panel families. And to talk about this, they are on page 9. This could be a course unto itself. The only problem with this course is that nobody would go, because the kind of budgets that we have here on the West Coast don't really lend themselves to the panelization process, but I just want to touch on it so you know how it works. So there's special kinds of families which you can build from File, New, Family, and then in here there is a curtain panel pattern base. So that's a special kind of, don't open it up, your brain will explode. They really are their own kind of animal, and I do not want to get into them much at all. But the thing is that in these templates you can choose whether it's going to be a rhomboid pattern or triangles or what have you. Now what you folks can do, and I would advise that you do this, go to the Insert tab. Actually, don't even bother with the Insert tab. Open up File Explorer on your computer. Hold down the Windows logo and type E. Windows logo and type E to bring up the File Explorer on Windows 10. Now, at the top of the screen here, put your cursor up at top and then backspace to get rid of the path. Now you guys probably know about drag and drop, but this will be the easiest way to get us all there so you can drag and drop the families in. So go to J:\\, BLDG \, 2805 \, and then hit enter. J:\\, BLDG \2805, and hit enter, and then go into the Session 4 folder. Now there's a couple of families in here that are curtain panel pattern-based families. It's the triangle and the space frame. Now what I want you guys to do is to just right now take the triangle family and drag and drop it into Revit. Drag, drop, release. Presumably, Revit will show you the panel right here. So I'm going to load this into my project in a second. Anybody not getting this? If you are, just wave. We'll send Henry right here. Okay. So grab the triangle. Where's the triangle? Oh, no, there's the triangle. Yep, drag and drop it to your block right here. Yep, release. Oh, okay, so insert it there. Oh, I see, because you're not inside. Okay, you have to panelize it. So just insert this is the template that these pattern-based panels are built from. It's a pretty strange process, and I don't actually use it that much, but some architects do. Choose load into project if you folks see it on your screen, or load and close, and it'll get added to your project. Now in 3D, on the part where you created the grid, so when you folks have made a grid on the surface of your mass, in the properties palette, when you load it in that triangle, if you scroll on down to the bottom here, you'll see triangle listed under the triangle pattern. So here's the deal. This initial, or this first mention here, is a placeholder. It's meant to show you how the triangle pattern will look on this part of the building. But if you load in one of these curtain panel pattern-based families, whatever pattern it was used, was built on, whichever pattern it was built on, it will show up in the list underneath the placeholder. And now, there it is. So now you can see the, if I turn on shading here, you can see the geometry when this panel is being used in this location. Now I want to get, so you folks can all at least get to this point here, and then we'll move on. So if any of you are having trouble getting the pattern family to appear, like you see on the screen here, wave and we'll help you out. Now the other thing I'm going to do here is I'm also going to bring in the other panel here. It's the space frame panel rhomboid. I'm going to pull that in as well. And this is a true space frame concept here. So rhomboid, there we go. Doesn't matter which one you choose. There. So this thing is actually got all the tubes and all the pipes and bracing and the glass for building a true space frame. It's a little clunky looking in comparison, I guess, but it's doing it. So each side of the building has to have, or each face has to have the surface divided. And so once each surface has been divided, now it can have the appropriate pattern-based family applied to the face of it. So this will allow us to take each particular massive face and apply either the grid so we can see how it looks, or we can get one of these special pattern-based families, and when you click on a face that's had a grid applied to it, then in the properties palette we can pull down that menu, pull down and use one of those pattern-based families. Now this is kind of a niche thing, right? Because as you can imagine, this is pretty expensive stuff. I do know of a curtain wall company in Kamloops. They specialize in this all across North America. They're doing this stuff all the time, and they're doing it in Revit. So they're doing this exact workflow. And they're sending their stuff right from Revit, the curtain wall, right to the cutting room floor. So they've got a really high-tech process of taking the curtain walls that they're building in Revit using massing, and then in the shop floor they're building all the extrusions from it. It's an amazing accomplishment what they've done up there. But alas, that is not us. So what we're going to do here is we're going to, you folks can save this, so you just got a record of it, but what we're going to look at instead is massing of structure on existing geometry. It's page 10. Now I am going to go through with you folks the massing and steel roof framing, and I'm only going to spend about maybe 5-10 minutes on this last piece of tonight's work, because I want to talk about the term project and leave some time for questions. So this is probably the application for massing that most of us would find the most useful. In the same folder tonight, our session 4 folder, you folks should find the generic model, no, massing on steel roof framing. Massing on steel roof framing. We actually talked about this a little bit when we were talking about structure last week. Massing on steel roof framing. So again, this is in the session 4 folder. There's the file right there, massing on steel roof framing. There are some other files in here that talk about the applications for massing and some other families called adaptive components, which are there if you're interested in them. Oh, this is exciting. So what we have here, it's actually, there's massing going on here. Now, once this thing is opened up, if you folks click this black line that you'll see in the foreground here, it's just a model line here that allows us to pick it and go into the edit, to edit the in-place family. This is an in-place mass family. So if you remember last week when we talked about when we're sloping a roof with structure. So we're not using tapered insulation, we're using a constant thickness of rigid insulation on top of our roof. And so at the perimeter, we've got a situation where the structure is all at the same height. So our roof decking all around the perimeter is at one elevation. And then on the inside, our structure is sloping to drain. Now this creates a real difficulty to model this in Revit because none of these joists are on the same slope. They're all at different slopes. It's a nightmare. Trying to model the roof that sits on that, you can see the roof would all be at the same height along the edge, but on the inside, the roof is going to go up and down. In-place family? Suicide? What? So as an alternative to killing yourself, which we don't recommend, use the in-place family. Your mental health is important. Use the in-place family. So once you are inside the in-place family, you folks will see that there are reference lines. And the way the reference lines have been put down is that we use the reference line tool and we turn on 3D snapping. And what we do is we snap to the top center of the beam and then we go along to the corner where I've got my little HSS cheater tube here that I've drawn, and I snap it, it goes right into the corner, and then I come along down here and hit my, finally, my, I start from the center of the HSS tube there. There's an HSS tube there, by the way, folks, you see it here? So I'm not following the joists, because the joists are a mess, they're all over the place. I go from the center of my HSS tube to the wall, along the wall, along the wall, and then from my HSS tube, center of it, out to the wall here. So what I have in each given bay, steel beam going down to the HSS tube, steel beam going up to the next HSS tube. So in this one bay, I have 1, 2, 3, 4 reference lines. And what I do, and what you're going to do right now, is we're just going to give a go at making a mass with those 4 lines. And the important thing to note is that those reference lines must all snap nicely together. Now in Revit, you don't have to be too, OCD or anal retentive about what things snap to. But in this case, you kind of have to be careful because all these reference lines must snap neatly together so that we can create a mass from this intersecting geometry. So that's been done here, so you don't have to worry about that. So let's make a mass together. Watch the screen. Here's how it's done. We want to get just these 4 reference lines around this one bay. So there's one. So we click it. Now, I'm going to go to the outside wall. Revit wants to grab all those reference lines along the edge. I only want one of them. So you hover. You hit the tab key once. It picks that one reference line, and to select it and add it to the reference line we've already got selected, Control. Hold down Control. And now you can click it, and now we have, oh, poop. Tab, Control, click. Now we have two reference lines selected. You folks can see it down here on the status bar. Now we need a third reference line, so we move up. Revit wants to grab two of them. I don't want two, I just want one. So I hit the tab key once. Great, it's highlighted, and now to add it to the selection set, I Control, see, plus on my cursor, Control, click it. One more reference line to grab, this one here. Control, click it as well. You should have 4 reference lines selected. And this is one of those awkward things about using Revit is the hover tab click in conjunction with the Control key. So again, I'll do it here. Click, Control click, hover, too many, so I hit the tab key, Control click, hover, too many selected, so I hit the tab key, Control click. 4 reference lines. From this, I can make a mass. So we're making a solid form. But this time, I don't want a solid. See down on the bottom there, Revit's saying, hey, do you want a solid or a surface? You want a surface. You want a surface. And so now, we've got a mass surface that follows the contour of what we've drawn here. So each of these mass surfaces are, they're a little bit twisted. Finish the mass, and then we'll show you how to use the roof by face tools. So those gray planes that you see there represent the underside of deck that will get attached to the steel joists being used in this building. So when you go to the Architecture tab and you use the Roof by Face tool, Roof by Face, so in here I'm going to go and grab the insulation and metal deck here. What am I picking? The top of the roof or the bottom of the roof? So when I pick this mass face, is that the top of my roof or the bottom of the roof? It's the bottom. So I got to switch here. Face is at the bottom of the roof. And so I put my cursor over this thing and I click it and hit Create Roof. Then I go to the next square, click it, Create Roof. Next square, Create Roof. So each one of those roofs, my insulation is too thick. You can see my roof is actually thicker than the outside wall. Each one of those roof objects now exactly follows the contour of my joists and of my structure. So, wicked boring building. Like, you just can't get any more boring of a building than this. But we have to go through this relatively complicated process to build a roof that sits on top of that structure. All right, we're out of the lecture for tonight. We're going to talk about the term project. Now, maybe what I'll do here, well, I guess I can keep on with using my laptop here. So in the share out folder in our BLDG 2800, 2805 rather. We have our term assignment. So I'm going to download this to my computer. All right. So in the folder here, there is a PDF talking about the different sheets that are required for the term project and a little bit of a description of what's going on here. So we'll talk about that term project right now. So what we are building is the Lummelson winery, which is in Oregon. Fat chance that Google Earth has modeled it. No, of course they have not. But we can go and grab the little man here and, what? Oh, okay. The Google car hasn't been everywhere, who knew? That's a fine view of the, there was a picture of it there, so you can see, oh, that's it up there, so that's as much as we're gonna see of it. Okay. So that is the building right there. I took a tour of this building years ago. And we've got some pictures of it in our folder here. And what's unique about this building is that it's extremely quiet. So I'll leave this section up on the screen, and then I'll also open up the files that we're using. Now, this is kind of like a seed file that you can start the term project from. It has the various levels already created. So it's got the main floor at 100 feet, and then the other floors for the building. So you don't need to create the floors of the plan views, they're already created. In each one of these plan views, I've drawn some room separation lines. That's what the purple lines are. And I've put in some room objects that give you the general arrangement of the space, similar to the building itself. So here's the deal. The building has 3 levels. You've got your main floor, where the wine is pressed, the grapes are brought in, and there's a retail area. Now what they've done in this winery is, once the grapes have been pressed, so this is the top level here, when they're ready to send it down for settling, instead of using pumps, they've got a mezzanine level halfway between the main floor and the basement. So when they're ready to send the grapes off for settling after it's fermented, they just open the valves, and it drains by gravity down to the settling room. And there they let the grapes, the sediments, fall out of the juice, and then they open up the valves again, and it drains by gravity down to the basement for casking. Now, if you've ever been on some wine tours in the Okanagan, they can be quite noisy places. And the one thing that's really interesting about the Lummelson winery is how quiet it is, comparatively. So they do everything by gravity there. So you can kind of see what the architecture of the building looks like, siding on the outside. You do not have to use that look at all. You can feel free to design whatever you want, or if you're not interested in doing any design and just want your damn mark, you could just use that and roll with it. So in the Revit model, we have the fermentation room, the light well, which separates, so that's this part here, which separates the fermentation room, and it's mostly open. There's some posts in here, so inside the winery you can look down from the fermentation room down to the casking room, and there's this light well which goes all the way to the basement, and there's some skylights above, which you can see. Well, they're kind of back in here. They're in line with the metal roof. So we have our mezzanine level, right? So that's this area here. There's the light well right there. And then we have our lower floor. So there's the circulation, which is of course underneath the light well. Cask storage on each side. So you've got 3 different levels plus your roof. So what's going to happen is that we're going to employ phasing. So on the main floor, we're going to have a big deck out here, which will be built in phase 1, and then you folks will add another phase, which will be the phase 2, where the restaurant will be filled in. Now you don't have to draw tables or any of that stuff. You just got to take that deck and provide walls around the outside. So in phase 1, you've got your railings on the outside, demolish those in phase 2, and then just put in the walls. So you've got all the different levels there. Now in fact, if you look at this thing in 3D, you can see all the room separation lines, and you can kind of see how the space is laid out. So there's our settling room on the mezzanine, and then our top floor up here. So what you can start doing is laying out the walls for this and start thinking about your design, and of course setting up your phasing. And there's going to be design options that are required as well. So if we look at the term project requirements, get rid of the room separation lines once you've got the walls in there. Keep the general arrangement. For the washrooms, just show the toilet stalls and fixtures, but you don't have to go into any detail on the restaurant or the kitchen. So you can show seating in the restaurant, but don't worry about getting into any great detail. We are going to model the wine tanks. So the different tanks that you see in the PDF sections here, these ones here, we're going to model these tanks. Not in any great detail, but we are going to model them. So have a look at the requirements here in our TURB assignment handout. So there's the sheet list there, sort of suggested number of pages. If it says a plus on it, it means you should have at least 1 page. And if there are more plan pages needed, then just add them as needed. On the second page, we have some description of the requirements here for what you're going to be putting into the project. So just as we demonstrated on the first night of the course, we're going to be using a linked building and site method. So what we have here, the other file that's provided, is a model of the site. And I've got a filled region here showing the 3 properties on which your building will be built. So basically the grapes will be grown on the south edge of the property, and you're going to place the winery up here in the northwest corner at the high point. So this survey file does of course have all the topographic lines in it, and the only layers that you need to build the topography are the orange and brown ones here. So this is 3 contour intermediate and 3 contour index. So it's just those 2 layers that we're interested in building the topographic model. So once you've imported your building, you've linked your building onto the site, move it into place. So go back and look at the week 1 notes with regards to the linking of the building onto the site and setting up of the site plan. So you probably don't have to start working on the site plan right now, but I would definitely start working on the building and getting things laid out here and getting familiar with the term project requirements. Okay, so I'm going to end the recording right now, and I'll get these up online here in a few moments. And yeah, any questions that you folks have, we'll help you with that right now.